Did you know a single Rolex watch can contain over $50,000 worth of precious metals? With that kind of material value, you're wearing what could buy a brand new luxury car, just in raw gold and platinum. But here's something most people don't know. Rolex doesn't just buy finished precious metals from suppliers and shape them into watches. They actually operate one of the most advanced precious metal foundries in the entire watchmaking industry, transforming raw materials into custom alloys that exist nowhere else on Earth. From 24-karat gold bars delivered under armed guard to proprietary pink gold formulas that never fade, every gram of precious metal in a Rolex tells a story of extreme precision, obsessive quality control, and a relentless pursuit of perfection that has defined this Swiss icon for over a century. In this video, we're taking you deep inside Rolex's precious metal operations, from the secure vaults where millions in raw materials are stored to the metallurgy labs where scientists create alloys that will outlast their owners by generations. If you've ever wondered what makes a Rolex worth its price tag, or how raw gold becomes a timepiece that can cost more than a house, hit that subscribe button right now. Smash that like button. Share this with anyone who appreciates true craftsmanship. And drop a comment telling us, would you spend $1 million on a watch if you had the money? Let's uncover the golden truth. The Swiss watchmaking paradox sits at the heart of luxury timepiece production, and nowhere is this more apparent than in how Rolex approaches precious metals. When most people think of luxury watches, they imagine craftsmen assembling tiny gears and springs in workshops that look like they haven't changed since the 1800s. But the reality of modern Rolex production is far more complex and technologically advanced than most enthusiasts realize. Here's what separates Rolex from virtually every other luxury watchmaker. While brands like Patek Philippe, Audemars Piguet, and Vacheron Constantin purchase their precious metal components from specialized suppliers, Rolex does something almost unheard of in the industry. They manufacture their own alloys from scratch. The company operates a dedicated foundry called Plain-les-Ouates on the outskirts of Geneva, a facility so advanced that it rivals the capabilities of aerospace and medical device manufacturers. This isn't a small operation or a token gesture toward vertical integration. Rolex employs over 40 metallurgists, material scientists, and specialized technicians whose sole job is perfecting the precious metals that will eventually grace the wrists of presidents, celebrities, and collectors. These aren't jewelers or watchmakers. They're scientists with advanced degrees in materials engineering, chemistry, and physics working in laboratories that look more like something from a pharmaceutical company than a watch factory. The decision to bring precious metal production in-house wasn't made for marketing purposes or brand prestige. It was made because Rolex discovered that the standard gold alloys available from suppliers couldn't meet their requirements for color stability, scratch resistance, and longevity. Traditional 18-karat rose gold, for example, contains copper which oxidizes over time, causing the warm pink hue to gradually shift toward a duller, more reddish tone. For a company that builds watches meant to last generations and maintain their value, this was unacceptable. So Rolex did what Rolex does. They engineered a solution from the atomic level up. The result was Everose gold, a proprietary 18-karat pink gold alloy that includes a small percentage of platinum to stabilize the copper and prevent oxidation. This formula is exclusive to Rolex, patented and protected, and it produces a color that will look identical in 100 years as it does the day it leaves a factory. But Everose is just one example. Rolex has also developed their own versions of yellow gold, white gold, and even a platinum alloy optimized specifically for watchmaking. Every precious metal Rolex uses is custom formulated, tested to destruction, and manufactured to tolerances that exceed industry standards by orders of magnitude. This level of control comes at enormous cost. Operating a precious metal foundry requires millions in equipment, specialized facilities with precise environmental controls, and teams of highly educated experts. Most watch companies rightly concluded decades ago that outsourcing metal production made more financial sense. But Rolex has never been a company that makes decisions based solely on short-term economics. Their foundry represents a long-term investment in quality control, supply chain independence, and the ability to innovate in ways that competitors simply cannot match. The journey of precious metals through Rolex's operations begins not in Switzerland, but in refineries around the world where raw gold, platinum, and silver are purified to exacting standards. Rolex sources its precious metals exclusively from certified refineries that meet strict ethical and environmental requirements. This isn't just about quality. It's about ensuring that every gram of gold in a Rolex can be traced back to the supply chain to verify it wasn't mined using child labor, didn't fund armed conflicts, and came from operations with proper environmental safeguards. The company works primarily with refineries accredited by the London Bullion Market Association, an organization that maintains the most rigorous standards in the precious metals industry. These refineries receive raw gold from mining operations and put it through multiple purification processes to achieve 99.99% purity, also known as 24 karat or 4/9 gold. At this purity level, gold is too soft for most practical applications. Pure gold can be scratched with a fingernail and would deform under normal wear. But this extreme purity is exactly what Rolex needs because it gives them complete control over what happens next. The raw materials arrive at Rolex's Plan Les Watts facility in the form of standardized bars, each one stamped with certification marks indicating its purity, weight, and origin. A typical delivery might include bars of 24 karat gold weighing 1 kilogram each, platinum bars of similar size, and smaller quantities of palladium, silver, and copper which will be used as alloying elements. These deliveries are made under security protocols that rival those used for transporting currency. Armored vehicles, GPS tracking, armed guards, and surveillance ensure that metals worth millions never leave the chain of custody. Upon arrival, every bar is immediately logged into Rolex's inventory management system, weighed to the tenth of a gram, and stored in climate-controlled vaults until needed for production. The security surrounding precious metals at Rolex isn't just about preventing theft, though that's certainly a concern when you're holding inventory that can exceed $100 million in value. It's also about maintaining absolute accountability. Rolex tracks every gram of precious metal from the moment it enters a facility until it leaves as part of a finished watch. This tracking system is so precise that the company can tell you exactly which bar of gold was used to create the case of any specific watch they've manufactured. This level of traceability serves multiple purposes. It satisfies increasingly strict international regulations around conflict minerals and responsible sourcing. It protects against counterfeiting by creating an unbreakable chain of custody, and provides quality control by ensuring that if a problem ever emerges with a particular batch of metal, every watch made from that batch can be identified and examined. The vaults themselves are architectural marvels of security engineering. Multiple redundant access control systems, biometric scanners, man-trap entrances, and monitoring systems that track not just who enters, but exactly which bars they remove and when. Environmental controls maintain constant temperature and humidity to prevent any oxidation or degradation of the stored metals. Even the lighting is carefully chosen to avoid any heat buildup that might affect the materials. The transformation of raw precious metals into Rolex alloys happens in a facility that looks nothing like a traditional jewelry workshop and everything like an advanced materials laboratory. The process begins in the metallurgy department, where teams of scientists work with equipment that can analyze metal composition down to parts per million and control temperatures to within a single degree. Creating an 18-karat gold alloy might sound straightforward. Mix 75% pure gold with 25% other metals, and you're done. But the reality is infinitely more complex. The properties of the final alloy, its color, hardness, scratch resistance, corrosion resistance, and machinability, depend not just on what elements you add, but in what proportions, in what order, at what temperatures, and how you cool the mixture. Change any variable, and you get a different result. Rolex's yellow gold alloy, for example, is 18-karat gold mixed with specific proportions of silver and copper. The exact ratios are proprietary, but the result is a rich, warm yellow that's slightly deeper in color than standard 18-karat yellow gold. More importantly, the alloy is harder and more scratch-resistant, while still maintaining the workability needed for the complex machining operations that will shape it into watch cases and bracelets. The white gold alloy is even more complex. Traditional white gold achieves its silvery color by alloying pure gold with palladium and silver, but the result often has a slightly yellowish tint that requires rhodium plating to achieve a true white appearance. Rhodium plating wears off over time, eventually revealing the off-white base metal underneath. Rolex rejected this compromise entirely. Their white gold formula uses carefully calculated proportions of palladium, silver, and platinum to achieve a naturally white color that never requires plating. The alloy is inherently white, meaning a Rolex white gold watch will maintain its color for an entire lifespan without any maintenance. Then there's Everose, perhaps Rolex's most impressive metallurgical achievement. Traditional rose gold, or pink gold, gets its color from copper mixed with pure gold. The more copper, the redder the color. But copper oxidizes when exposed to air, gradually darkening and shifting the color over time. For a watch that might be worn daily for decades, this aging process was unacceptable to Rolex's standards. The solution required years of research and experimentation. Rolex metallurgists discovered that adding a small amount of platinum to the gold and copper mixture stabilizes the copper atoms and prevents oxidation. The platinum acts as a catalyst, creating chemical bonds that lock the copper in place at the molecular level. The result is a pink gold alloy that maintains its exact color indefinitely, even after years of exposure to air, moisture, and skin oils. But developing the formula was only half the challenge. Manufacturing Everose consistently requires precise control over the alloying process. The metals must be combined at specific temperatures in a controlled atmosphere to prevent premature oxidation. The cooling rate must be carefully managed to ensure uniform crystal structure throughout the alloy. Even slight variations in process parameters can affect the final color. So every batch is manufactured under conditions that would satisfy aerospace or medical device standards. The alloying process itself takes place in specialized furnaces that can reach temperatures exceeding 2,000 degrees Fahrenheit while maintaining precise atmospheric control. Pure gold melts at 1948 degrees Fahrenheit, but adding alloying elements changes the melting point. So each formula requires different temperature protocols. The furnaces are equipped with inert gas systems that flood the chamber with argon or nitrogen, displacing oxygen and preventing any oxidation during the melting process. Metallurgists begin by calculating the exact weight of each element needed for the batch. This isn't done by volume or approximation. Every component is weighed on precision scales accurate to hundredths of a gram. For a batch that will produce enough alloy for 100 watch cases, the measurements might involve 7.5 kilograms of pure gold, 1.8 kilograms of copper, 600 grams of silver, and 100 grams of platinum. These components are loaded into a crucible, a specialized ceramic container that can withstand extreme temperatures without reacting with the molten metal. The crucible goes into the furnace, and the temperature is gradually increased according to a programmed heating curve. Rapid heating can cause thermal shock and create defects in the metal, so the temperature rises in controlled steps, allowing materials to equilibrate at each stage. As the temperature climbs above 1,900 degrees, the metals begin to melt. Gold liquefies first, forming a glowing pool in the bottom of the crucible. Then the other elements melt and mix with the gold, creating a molten alloy that glows bright orange in the darkness of furnace. At this stage, the mixture isn't yet uniform. Density differences mean the heavier elements settle while lighter ones float. This is where the real precision work begins. The crucible is subjected to electromagnetic stirring, a process that uses powerful magnets to create currents in the molten metal, thoroughly mixing the elements at the atomic level. This continues for a carefully timed period, long enough to ensure complete homogeneity, but not so long that the intense heat begins to degrade the crucible or affect the metal chemistry. Once mixing is complete, the alloy must be cooled, but not all at once. The cooling rate determines the crystal structure of the solidified metal, which in turn affects its mechanical properties. Cool too quickly, and the metal becomes brittle. Cool too slowly, and the grain structure becomes coarse, making the alloy difficult to machine. Rolex has developed proprietary cooling curves for each of their alloys, precisely timed temperature reductions that produce the optimal balance of hardness, ductility, and machinability. The molten alloy is poured from the crucible into molds, typically rectangular forms that will produce bars roughly the size of a chocolate bar. As the metal cools and solidifies, it's continuously monitored with thermal cameras and temperature probes. Any deviation from the planned cooling curve triggers alarms, and the batch may be rejected. After solidification, the bars undergo their first quality inspection. Samples are cut from each bar and sent to the analytical laboratory, where they're subjected to spectroscopic analysis. a technique that identifies the exact chemical composition by analyzing how the metal absorbs and emits light. The results must match the target formula within incredibly tight tolerances. If the gold content measures 74.9% instead of the required 75%, the entire batch is rejected and returned to the furnace for reprocessing. This might seem excessive. After all, the difference between 74.9% and 75% gold is barely measurable and wouldn't be noticeable to anyone wearing the watch. But Rolex doesn't build watches to barely acceptable standards. They build to the standards they've set for themselves, and those standards have no tolerance for close enough. Beyond chemical composition, the bars undergo testing for mechanical properties. Small samples are subjected to tensile testing to measure strength and ductility, hardness testing using diamond tip probes, and microscopic examination to verify grain structure. Only after passing every test does the alloy receive approval for use in watch production. The rejected batches, and there are always some, don't go to waste. They're simply remelted and alloyed again, the beauty of precious metals being that they can be recycled indefinitely without degradation. Once approved, the precious metal bars enter the next phase of transformation from raw alloy to precision components. This happens in the machining department, where computer-controlled equipment shapes the metal with tolerances measured in microns. A human hair is roughly 75 microns thick. Rolex machines their watch cases to tolerances of plus or minus 5 microns. The process begins with creating blanks, cylindrical slugs of metal that will eventually become watch cases. The approved alloy bars are loaded into CNC computer numerical control milling machines that cut them into precisely sized cylinders. These machines use diamond-coated cutting tools because precious metal alloys, especially those containing platinum, are incredibly tough and would quickly destroy conventional steel tooling. The cutting process is performed under constant flood cooling, streams of specialized cutting fluid that carry away heat and metal chips while lubricating the cutting tool. Temperature control during machining is critical because thermal expansion could throw off the dimensional accuracy. A piece of gold that's measured at room temperature will be slightly larger when heated by the friction of cutting. So all machining operations account for these thermal effects. From the cylindrical blank, the watch case gradually emerges through a series of machining operations. First, the rough external shape is cut, establishing the basic diameter and height of the case. Then internal features are machined, the cavity that will house the movement, the threads for the case back, the channel for the crystal gasket. Each operation is performed on specialized equipment designed for that specific task. The precision involved is difficult to overstate. Consider the threads that secure the case back. These must be perfectly concentric with the case axis, cut to exact depth and pitch, and finished to a smoothness that ensures water resistance to 100 meters or more depending on the model. The threading operation is performed by a CNC lathe that controls position to within 2 microns while the case rotates at several hundred RPM. A specialized camera system monitors the cutting process in real time, and if any deviation is detected, the machine automatically adjusts or stops and alerts operators. The case lugs, those projections with the bracelet attaches, present their own challenges. These must be shaped with compound curves that are both aesthetically pleasing and structurally sound, capable of withstanding the forces from a bracelet without bending or breaking. They're machined from the solid case body, not welded or attached separately, ensuring structural integrity. This means removing a lot of material, carefully carving away everything that isn't lug, leaving behind precisely shaped protrusions that match the design specifications perfectly. After rough machining, every case goes through a meticulous hand-finishing process. Despite all the advanced machinery, there are aspects of watch case finishing that still require human skill and judgment. Trained craftspeople use specialized tools to refine surfaces, creating a mix of polish and brush finishes that characterize Rolex cases. Polished surfaces are achieved through progressive refinement, starting with fine abrasives and working down to rouge compounds that create mirror-bright finishes. The polisher must maintain absolute consistency of pressure and angle, working the surface until it reflects like glass. Even a slight variation in technique will be visible in the final product, appearing as waves or distortions and reflections. Brush surfaces require equal skill but a different technique. These are created by moving fine abrasive pads across the metal in parallel strokes, creating a linear grain pattern that diffuses light and provides visual contrast to polished areas. The brushing must be perfectly uniform and exactly aligned, as any deviation from parallel is immediately obvious. On a Rolex case, brush surfaces on the case sides meet polished surfaces on the bezel, and lugs with absolute precision, crisp transitions that demonstrate masterful control. The bracelet creation process mirrors case production in complexity, but multiplies it by the number of individual links. A typical Rolex bracelet contains over 30 separate components, each one machined from solid precious metal with the same tolerances as the case itself. The center links, side links, end links, and class components all begin as machined blanks that are progressively refined through multiple operations. What makes bracelet production particularly challenging is that every link must be identical. If one link is even slightly wider or thicker than its neighbors, it will be obvious when the bracelet is assembled. Rolex manufactures links in batches but inspects them individually, using optical comparators that project magnified shadows of the parts onto calibrated screens where inspectors can verify that every dimension matches the specifications. The pins that connect the links are engineering marvels in their own right. These tiny components, barely thicker than a toothpick, must be strong enough to hold the bracelet together under daily, while being removable for sizing adjustments. They're machined from hardened steel with precision that ensures they fit the link holes with just enough clearance to install smoothly, but no so much that the bracelet develops play or wobble. Each pin undergoes automated inspection that checks diameter, length, and surface finish before approval. The bracelet clasp represents perhaps the pinnacle of Rolex's precious metal machining capabilities. This component must function flawlessly through thousands of open and close cycles while maintaining water resistance and looking beautiful. The oyster lock clasp used on professional models contains over a dozen individual parts, including springs, levers, and catches, all working together with clockwork precision. The clasp body is machined from solid gold or platinum with internal cavities and channels that house the mechanism. The tolerances here are even tighter than on the case because the clasp must operate smoothly while maintaining security. If parts fit too loosely, the clasp will feel cheap and may fail to lock properly. Too tight, and it becomes difficult to operate or may wear prematurely. The surface finishing applied to these components goes beyond mere aesthetics. The polishing and brushing serves functional purposes, improving corrosion resistance and wear characteristics while making defects or damage more visible for quality control. But there's no denying the visual impact. A properly finished Rolex bracelet catches and reflects light in ways that announce its quality from across a room. The interplay of brushed and polished surfaces creating depth and visual interest that lesser bracelets lack. With all components machined and finished, assembly can begin, but not before another round of quality control. Every case, every bracelet link, every class component undergoes final inspection before being cleared for use. This inspection combines automated systems and human expertise. Laser scanners measure critical dimensions, creating three-dimensional maps of each part that are compared against CAD models. Camera systems examine surfaces for scratches, blemishes, or finishing defects. And experienced inspectors examine each piece under magnification, looking for issues that automated systems might miss. The actual assembly of a Rolex watch takes place in clean room environments where temperature, humidity, and particulate levels are carefully controlled. Watchmakers work at stations equipped with specialized tools and microscopes, surrounded by parts trays organized with military precision. The movement, which arrives from a separate Rolex facility, is inspected and tested before installation. Then it's carefully lowered into the precious metal case, seated against gaskets that will provide water resistance, and secured to the case back that's threaded or pressed into place depending on the model. The crystal, made from scratch-resistant sapphire, is installed next, seated in a channel with a rubber gasket that's compressed as the crystal is pressed into place. The pressure must be precisely controlled. Too little, and the crystal won't seal properly. Too much, and it might crack. Specialized fixtures hold the case while hydraulic presses apply exact force, monitored by pressure sensors that ensure consistency. The bracelet is attached last, each end link fitted to case lugs and secured with pins that are driven into place with controlled force. The clasp is tested to verify smooth operation and positive locking. Then the entire watch undergoes final timing adjustment, a process where watchmakers fine-tune the regulator mechanism to ensure the watch keeps time within Rolex's standards of -2 to +2 seconds per day. After assembly, every watch spends time in pressure chambers that simulate diving to depths far beyond what the watch is rated for. Water resistance isn't just tested at the rated depth. It's tested at multiples of that rating to ensure a margin of safety. Watches that will be rated for 100 meters are tested at pressures equivalent to 125 meters. Dive watches rated for 300 meters face tests, simulating 375 meters. Any watch that shows the slightest hint of moisture infiltration is immediately disassembled, examined to identify the failure point, repaired or rejected, and tested again. Timing performance is evaluated over multiple days in different positions and temperatures using atomic clock references. The watch is placed in various orientations: dial up, dial down, crown up, crown down, and its rate of gain or loss is measured. Temperature is varied from near freezing to body temperature and beyond. Only watches that maintain accuracy within specifications across all these conditions earn approval. But Rolex's quality control extends beyond functional testing into areas that most manufacturers wouldn't bother with. Every watch undergoes aesthetic inspection, where trained specialists examine the dial printing, hand installation, and marker alignment under magnification. The hour markers must be perfectly aligned both radially and rotationally. The hands must be precisely centered on their arbors and must clear each other and the dial by specific distances. The dial printing must be crisp, correctly positioned, and free from any spots or imperfections. This inspection catches issues that customers might never notice, but that fail to meet Rolex's internal standards. A dial where the logo is printed 1/10 of a millimeter off-center will be rejected even though that deviation is barely measurable with precision instruments. A hand that installs slightly askew, creating microscopic asymmetry that only becomes apparent under magnification and careful measurement, is cause for disassembly and correction. This obsessive attention to detail is what separates truly exceptional manufacturing from merely very good manufacturing. It's also expensive, time-consuming, and from a pure profit perspective, probably unnecessary. But it's core to Rolex's identity. The company has built its reputation on the premise that a Rolex is built without compromise, that every watch meets standards that exceed what customers expect or competitors deliver. This philosophy pervades every aspect of their precious metal operations. Consider the recycling systems in place throughout the facility. When precious metal is machined, the waste material is carefully collected. The cutting fluid is filtered to remove metal particles. The swarf, those tiny metal chips created by machining operations, is gathered from machine sumps. Even the air filtration systems in the machining department are designed to capture airborne metal dust. All of this material is collected, sorted by alloy type, and sent back to the foundry for reprocessing. Nothing is wasted. Rolex operates a closed-loop system where scrap rates are measured, analyzed, and continuously reduced through process improvements. A machining operation that currently wastes 30% of the metal put into it becomes a target for optimization. Engineers study the process, adjust tool paths, modify fixtures, and implement changes that drop the waste rate to 28%, then 25%, continually improving efficiency while maintaining the same quality standards. This isn't driven by cost savings alone, though precious metals are expensive enough that waste reduction has obvious financial benefits. It's driven by Rolex's engineering culture that seeks continuous improvement in every measurable parameter. Waste is inefficiency, and inefficiency suggests that the process isn't yet optimized, that there's still room for improvement. For a company that strives for perfection, that's unacceptable. The environmental implications are significant too. By minimizing waste and operating a closed-loop recycling system, Rolex reduces the total amount of newly mined precious metals needed to support their production. Every gram of gold that's recycled from scrap is a gram that doesn't need to be extracted from the earth. Given the environmental impact of gold mining, this makes a meaningful difference. The finishing touches applied to Rolex precious metal watches occur in departments most people never hear about. There's an entire team dedicated to gem setting for models that feature diamond hour markers or bezels. These craftspeople use microscopes and precision tools to create settings that hold each stone securely while maximizing its brilliance. The process begins with drilling precisely positioned holes in the dial or bezel where stones will sit. These holes are drilled with tolerances tighter than the stone diameter because the setting will involve displacing metal to grip the stone's girdle. Each hole is carefully deburred and smoothed, then the stone is placed and secured using specialized setting techniques. For diamond hour markers, the most common approach is bead setting, where tiny beads of metal are raised around the stone's perimeter and burnished down over the girdle, gripping it securely. This requires enormous skill because the metal must be displaced evenly around the entire stone. Uneven setting will cause the stone to tilt, affecting how light enters and exits, diminishing its brilliance. After setting, each stone is inspected under magnification to verify alignment and security. The setting metal is examined for cracks or defects that might allow the stone to work loose, and the overall appearance is evaluated to ensure consistency across all markers. On a dial with 10 diamond markers, all 10 must appear identical in size, height, and brilliance. Bezel setting presents even greater challenges, particularly on models like the Day-Date, where 52 diamonds encircle the bezel. These stones must be graduated, slightly larger at the 12 o'clock position, and progressively smaller as they approach 6 o'clock, creating visual balance. But the graduation must be subtle enough that no individual stone stands out as obviously different from its neighbors. The setter must work with stones that vary by fractions of a millimeter in diameter and set them with precision that ensures even spacing and alignment all the way around the bezel. For gem set models, Rolex sources only the highest quality stones, typically VS Clarity or better in F color or better for diamonds. These specifications ensure that even under magnification, the stones appear flawless and colorless. Cheaper watches often use lower-grade stones that might have visible inclusions or yellow tints, but Rolex maintains standards that ensure their gem-set watches display the same attention to quality as every other aspect of their production. The final step before Rolex leave the factory is casing, which oddly enough refers not to the watch case, but to placing the watch in its presentation box. These boxes are themselves products of careful design and manufacturing, constructed from materials chosen for durability and aesthetics. A Rolex box must protect the watch during shipping and storage while presenting it in a manner befitting a luxury timepiece. Inside the box, the watch sits on a cushion that holds it securely while displaying attractively. The guarantee papers are included, documenting the watch's serial number, model reference, purchase date, and dealer information. These papers are critical for warranty service and significantly affect resale value, as a Rolex without papers sells for substantially less than an identical watch with complete documentation. Also included are instruction manuals, typically in multiple languages, that explain the watch's functions, care requirements, and warranty terms. For precious metal models, there's often a small tag attached to the bracelet that identifies the metal type, providing legal disclosure of the gold or platinum content. With everything in place, the box is sealed and prepared for shipping to authorized Rolex retailers around the world. These shipments occur under security protocols similar to those used when raw materials arrive at the factory. Watches worth hundreds of thousands or even millions of dollars are transported in armored vehicles with GPS tracking and armed security. The dealers receiving these watches maintain insurance policies, security systems, and inventory controls that satisfy Rolex's requirements. Unauthorized dealers don't exist in Rolex's distribution system. Every retailer is carefully vetted, contractually obligated to maintain specific standards, and regularly audited to ensure compliance. This tight control over distribution is another way Rolex maintains brand integrity. They know where every watch goes, who buys it, and can track it through the authorized service network throughout its life. The prices commanded by Rolex precious metal watches often shock people unfamiliar with luxury watches. A Day-Date in 18-karat gold starts around $40,000 and can exceed $100,000 for models with gem-set bezels. Platinum models push even higher, with some versions approaching or exceeding $200,000. These prices seem astronomical until you understand what goes into creating these watches. Start with the raw materials. The case and bracelet of a Day-Date contain approximately 100 grams of 18-karat gold, which at current prices represents about $4,000 in metal value alone. Platinum models use similar weights of metal worth 3 times as much. Then consider the manufacturing costs. The metallurgy, machining, finishing, assembly, testing, and quality control involve hundreds of hours of labor by highly skilled specialists using millions of dollars worth of specialized equipment. The development costs for proprietary alloys like Everose, amortized across production runs, add to each watch's cost. But beyond materials and labor, you're paying for Rolex's reputation, earned over more than a century of delivering watches that perform exactly as promised decade after decade. You're paying for the service network that can maintain and repair your watch anywhere in the world. You're paying for the resale value, as Rolex watches hold their value better than almost any other consumer product, with some models actually appreciating over time. And perhaps most importantly, you're paying for the satisfaction of owning something built to standards that prioritize perfection over profitability. When Rolex decided to develop their own precious metal foundry, they made a choice that reduced margins and increased complexity in exchange for control and quality. That choice ripples through everything they do, from sourcing ethically produced metals to testing each watch beyond its specifications. The result is a product that justifies its price not through marketing or artificial scarcity, but through tangible excellence in every measurable dimension. The future of precious metals at Rolex seems to involve continued refinement of existing alloys and possible development of new ones. The company has filed patents for various metal treatments and compositions, suggesting ongoing research into ways to improve scratch resistance, color stability, or other properties. There's also growing interest in sustainability throughout the luxury watch industry. Rolex has made commitments to responsible sourcing and reduce environmental impact, and their closed-loop recycling system positions them well to meet increasingly strict standards. Some industry observers speculate that Rolex might eventually develop alloys using recycled precious metals exclusively, though the technical challenges of maintaining consistent composition with recycled materials are significant. Whatever directions Rolex pursues, their fundamental approach to precious metals is unlikely to change. The company has invested too heavily in their foundry capabilities and built too much of their reputation on material quality to abandon vertical integration. If anything, expect them to dig deeper, finding new ways to improve alloys, reduce waste, and push the boundaries of what's possible in precious metal manufacturing. Every Rolex that leaves planless watch represents not just months of work by hundreds of specialists, but decades of accumulated knowledge and continuous improvement. The case that takes hours to machine reflects years spent optimizing tool paths and fixture designs. The bracelet that feels substantial and moves fluidly embodies countless small refinements in link geometry and pin diameter. The clasp that locks with satisfying click is the result of obsessive testing and adjustment of spring tensions and lever angles. This accumulation of incremental improvements, each one barely noticeable in isolation but collectively transformative, defines Rolex's approach to manufacturing. They don't pursue revolutionary changes or dramatic innovations. They pursue relentless refinement, the patient work of making good things better and better things excellent, and excellent things as close to perfect as human ingenuity allows. The precious metals that form these watches are among the rarest materials on Earth, and Rolex treats them accordingly, with respect bordering on reverence. But more than that, they see these metals as raw materials with potential waiting to be unlocked through knowledge, skill, and uncompromising standards. Gold doesn't become a Rolex case simply by being melted and poured into a mold. It becomes a Rolex case through dozens of precisely controlled steps, each one performed to specifications that exceed industry norms, each one contributing to a final product that will outlast its original owner and potentially serve multiple generations. The story of Rolex's precious metal operations is ultimately a story about choices, about deciding that good enough isn't good enough, that standards matter more than convenience, that quality justifies cost. It's about choosing to build a foundry when buying alloys would be easier, choosing to test beyond specifications when meeting them would suffice, choosing to reject parts with flaws invisible to customers because those flaws violate internal standards. These choices accumulate into a reputation, and that reputation becomes valuable in its own right. When someone chooses to spend $50,000 or $100,000 or more on a watch, they're not just buying metal and mechanism. They're buying confidence that the watch will perform flawlessly, that it will look as good in 20 years as it does today, that if something goes wrong, it can be repaired to factory specifications anywhere in the world. They're buying the satisfaction of owning something built without compromise, and they're buying into a tradition of excellence that spans generations. The knowledge that their watch was built with the same obsessive attention to detail that characterized Rolex watches built 50 years ago and will characterize watches built 50 years from now. That continuity of purpose and standard is rare in modern manufacturing, where quarterly earnings pressure constantly pushes companies toward cost-cutting and corner-cutting. Rolex's private ownership structure frees them from those pressures and allows them to make decisions based on long-term brand building rather than short-term profit maximization. The precious metal foundry is expensive to operate and probably doesn't generate positive returns measured over just a few years. But measured over decades, it's central to maintaining the quality and consistency that justify Rolex's prices and reputation. From 24-karat gold bars delivered under armed guard to finished watches that grace the wrists of the world's most successful people, the journey of precious metals through Rolex's operations reveals a company that has mastered the art combining traditional craftsmanship with advanced technology. Their watchmakers still assemble movements by hand under microscopes, yet those movements are housed in cases machined by computer-controlled equipment that can position cutting tools to within microns. The finishing work that creates the signature mix of polished and brushed surfaces involves hand tools and human judgment. Yet the surfaces being finished were machined to tolerances that human hands could never achieve unaided. The synthesis of old and new, of craftsman and machine, of art and engineering, defines modern luxury watchmaking at its highest level. And nowhere is it practiced more thoroughly or successfully than at Rolex, where every decision from alloy formulation to quality control procedures reflects an organization-wide commitment to excellence that accepts no compromises. The watches that emerge from the system command premium prices and earn enduring loyalty from customers who recognize that true quality is never an accident, but always the result of deliberate choices made consistently over time. You just travel with us in the secure vaults holding millions in raw precious metals to the clean rooms where those metals become some of the world's most desired timepieces. If after watching this video you see luxury watches differently, understanding that the price reflects not just marketing but genuine excellence in materials and manufacturing, we'd love to hear your thoughts. Drop a comment below and tell us honestly, would you save for years to buy a Rolex if you knew everything that went into making it? Or does the price still seem impossible to justify? And if this journey changed how you think about what separates true luxury from mere expense, hit that subscribe button, smash the like button, and share this with anyone who appreciates real craftsmanship so you won't miss our next exploration into the factories and facilities that create products at the absolute pinnacle of human manufacturing capability. From raw gold bars to million-dollar timepieces, now you know the golden truth behind every Rolex.